Okay, so in here you're being asked to write a polynomial being given a graph. So in here, we're just gonna write the polynomial in factor form. But before doing that, you need to be able to read the graph, list some important information, and use that to help you write out the full polynomial. So you're gonna need some things first. You're gonna need the x-intercepts. So the first x-intercept is at x equals 1. X equals minus 1, that is. And then we're gonna write if the graph crosses through the x-axis or bounces off the x-axis. So the graph bounces off the axis because it doesn't go through the x-axis. So this one is a bounce. And at that root, our multiplicity will be a multiplicity of 2. Because whenever the graph bounces off the x-axis, you have a multiplicity of 2. Since it's even, and that's the least possible multiplicity in there. Now let's look at the other x-intercept. The other x-intercept is all the way over here at x equals 4. Don't forget x-intercepts are numbers where the graph crosses through the x-axis. So at x equals 4, the graph crosses through the x-axis. And now, since it's a cross, our multiplicity is going to be odd. And the least possible multiplicity is 1 in there. So bounces, multiplicity of 2, crosses, multiplicity of 1. And at x equals 4, the graph crosses. And don't forget, x-intercepts are points where the graph touches the x-axis. I know earlier I said crosses, but I should be more specific and say it touches the x-axis. So at this point, the graph touches the x-axis. At this point, the graph touches the x-axis. This is not an x-intercept because the graph is touching the y-axis, not the x-axis in there. Now we're ready to write out the full polynomial. So before doing that, let's look at our end behavior. So as the x values get smaller, the y values are going down. As the x values get bigger, the y values are going up. So that means we're going to have an odd degree polynomial, and it's going to be with positive leading coefficient. So to write out the full polynomial, we're just going to write f of x equals, I don't know what my leading coefficient is, so I'm going to write the letter a. And I'm going to start writing the factors using the information from the x-intercepts. So the first x-intercept was at x equals minus 1, so my factor is going to be x plus 1. My multiplicity was 2 of that factor where that root came from, so x plus 1 will get a power of 2. Now the second root is at x equals 4, so my next factor will be x minus 4. Don't forget 4 and minus 4 are opposite signs. So that has a multiplicity of 1 in there, so that factor gets a power of 1. So I have x plus 1 to the power 2, x minus 4 to the power 1. And now what I have to do next is, I don't just leave my polynomial like that. I have to find my leading coefficient. And how I do that is I pick any point on the graph. The easiest point to use is a y-intercept, since that's where x equals 0. So we're going to choose a point to help us find our leading coefficient. So the point is 0 minus 1. So we're going to use the y-intercept. So now what I have to do is for x and y, I'm going to plug in those values and find my a in the polynomial. So f of x is the same thing as y. So f of x is negative 1 equals a times x is 0, 0 plus 1 squared, x is 0 there, times 0 minus 4. So negative 1 equals a times 0 plus 1 is 1. That gets the power 2. 0 minus 4 is negative 4. And I'm going to simplify that a little more. I'm solving for a. That's what I'm doing. I'm solving for a. Because I want to find that leading coefficient. So that is a times 1. Because 1 squared is 1 times negative 4. Negative 1 equals a times negative 4. Divide both sides by negative 4. So a equals 1/4. So my answer, my full polynomial, is 1/4 times, because a gets replaced with 1/4. Like that. So this a gets replaced, oopsie, with 1/4. So my answer is 1/4 x plus 1 squared times x minus 4. Don't forget to put f of x equals. That's sloppy. So it's f of x equals 1/4 x plus 1 squared times x minus 4. Okay, that is my answer.